Hey everybody, we're back at it talking about Unit 2 and things that deal with matter. Specifically, in this video, we're going to talk about Chapter 14 and dealing with isotopes. One of the things that we need to keep in mind is that the elements are made up of 3 different subatomic particles, for the most part. There's protons, neutrons, and electrons. Neutrons are what we're going to be dealing with here. So in order to do this, we need to know something about chemical symbols. Let's back up a little and do a quick review. Remember that elements are defined by how many protons are in the atom. Okay? So if elements are defined by the number of protons in the atom, what I know is that I can talk about an element that has 5 protons, and I can look at a periodic table, and on the periodic table, I can get that it's boron. Okay? I go to atomic number 5. Okay? Now, that already tells us how many protons there are in the element, but this video is dealing with isotopes, and isotopes are what happens when we have the same number of protons, but we have different numbers of neutrons. And in order to do that, we need to know a little bit about atomic symbols. Okay, now the symbols, yes, we get it, that there's symbols like Cl for chlorine, or H for hydrogen, O for oxygen, N for nitrogen, Fe is everybody's favorite special one, which is iron. All of those elements are symbolized using letters, but then we also add numbers to them sometimes, and we do this, we put down here in the lower left-hand corner, that's what I'm saying right here, the atomic number. So we kind of repeat this here. So this here is the atomic number, which again, if that's the atomic number, then that's the number of protons. And so notice here we have chlorine, and chlorine, if the element is defined by the number of protons, it stands to reason that both of these atomic numbers are the same. Now let's talk about this number on the top. This number on the top is different. And this is where we're talking about isotopes. We have the same element, so therefore we have the same number of protons, but notice this number on the top is different. This number on the top is called a mass number. What is a mass number? Well, a mass number represents the number of particles that have mass. So if we quickly go back to protons, neutrons, and electrons, and we look at their masses, what is the mass of a proton? 1. What's the mass of a neutron? 1. What's the mass of an electron? 0. So the mass number represents the number of protons plus the number of neutrons. So from these 2 pieces of information, we can get how many neutrons there are in a certain isotope. Homer Simpson would be so proud. Anyways, here we have a mass of 35 for this isotope. Okay, so that means that 17 of those of the mass is taken up by protons. So how many of the mass is neutrons? Well, 35 total minus 17 that are protons give us 18 neutrons. So this particular isotope has 17 protons, which we know because that's this number, and this number up here, it doesn't give us the number of neutrons, it's not 35, but it's related to how many neutrons there are. So now here's a different isotope. Now, what makes an isotope? An isotope is that it's the same number of protons. Again, I keep saying the same thing, beating it like a dead horse here. So it's same number of protons, but different number of neutrons. So here we have a mass number of 37, but 17 of those are protons. So that means that this guy has 20 neutrons. So we have one isotope that is 18 neutrons and another isotope which has 20 neutrons. So it's the same element, but it has different neutrons, and because the neutrons are different, it has a different mass number, a number up in the upper left-hand corner. So this is how we can tell. If we have isotopes of the same elements. We use the symbol to determine how many protons and how many neutrons there are. So I hope that clears that up and discusses how we determine isotopes. So have a great day.